define surface tension. Consider the free surface. Consider the free surface of a liquid. Imagine a straight line on this surface. This straight line, just imagine a straight line on the surface. This is acted upon by forces. Because the surface is behaving like a stretched membrane. So if you imagine a straight line lying on the free surface, that is under the action of forces. This force is suppose F and length of the line is L. Okay, length of the line is L. Suppose length of this imaginary line is L. Imagine this line. Then surface tension is defined as the force acting on unit length. So F equal to tangential force acting on a length L lying tangentially on the free surface of liquid. Tangential force acting on a length L lying tangentially on the force on the free surface of liquid. Then surface tension is defined as surface tension of liquid is known on a length L. Force F is acting. On unit length, F by L. What is the direction of surface tension force? Direction of surface tension force? Tangential. Tangential to the free surface of liquid. Tangential to the free surface of liquid. Okay. What is the unit of surface tension? Newton per meter. Okay. And surface tension depends on what? It depends on the substance. It depends on the substance. Surface tension of water 0.075 Newton per meter. Surface tension of mercury 0.465. It depends on substance. Surface tension of a liquid depends on the substance of the liquid Example, you have to memorize these two values. For water 0.075 Newton per meter. For mercury 0.465 Newton per meter. So from these two values, can you compare the cohesive force of water and cohesive force of mercury? Which material has a greater cohesive force? Mercury. Okay, remember surface tension is actually the effect of cohesive force. The cohesive force, there is tremendous cohesive force, surface tension is large. So mercury has greater surface tension, means cohesive force of mercury is large. You must have seen mercury that they always try to combine. If two mercury droplets come together, they combine to form a bigger drop. So that is because of high cohesive force. Okay. So surface tension depends on liquid. Change the liquid, surface tension will change. Actually. So now, we will find an expression for surface energy. Surface energy surface energy of a surface of liquid. Find an expression for surface energy of a surface of liquid. For this, first we will form a surface of liquid. We will form a surface of liquid. We will make an arrangement, a simple arrangement. We will use a piece of wire. We will bend that wire in this form, and we will take another piece of same wire. We will take another piece of same wire which we will use as a slider. Okay. Then we will prepare soap water solution. In a bucket we will prepare some soap water solution and we will dip this. Okay. If you dip, then a film will form here. Okay. Soap water film. So this is soap water film. What will you find? An expression for surface energy. Okay. Now let this be. This is B. Length of the slider is B. This is surface film, or this is soap water film. There is surface tension in it. What is the direction of surface tension? Tangential. Tangential. And what is its objective? It is always trying to reduce. It is always trying to reduce the surface area. Surface tension is continuously trying to reduce the surface area. Just like the surface of a balloon, the rubber of a balloon that is continuously trying to reduce the volume of the balloon. Okay. So since surface tension is trying to reduce the surface area, it is acting in this direction. This is surface tension. Okay. What is the unit of surface tension? Newton per meter. So how much force is acting on the slider? T into B. T is the force on unit length. T is the force on unit length. On B length, T into B. The actual force is not T into B. Actual force is T into B plus T into B. Because this film has, this is a film, it has two surfaces. This film has, just like the film, just like a paper, it has two surfaces. Any piece of paper, it has two surfaces. You can write on this side, writable surface. Think about writable surface. You can write on this side, you can also write on this side. So this film has two surfaces. Surface tension is acting on this surface and surface tension is also acting on this side. Okay, so total force acting on the slider, net force acting on slider due to surface tension, equal to T into B plus T into B equal to 2TB. Have you understood this part? That there are, think about writable surface. You can write on this side, you can write on this side. On this surface there is surface tension. On this surface also there is surface tension. So 2TB. Now you shift this. You shift the slider gently through a distance del x. Shift the slider gently through a distance del x. Okay. So in shifting the slider through a distance del x, you will have to do work against the force due to surface tension. Is it correct or not? You have to do work against this force, and this force being conservative in nature, whatever work you have done in shifting the slider, will remain stored in the surface as its potential energy. Okay, and that potential energy is called the surface energy. So work done by external agent in shifting the slider by del x equal to T into B plus T into B into del x equal to 2TB into del x, 2TB into del x, and 2TB into del x equal to, or del W, work done is del W, equal to T into 2B del x. What is B into del x? B into del x is the area of this portion. B into del x is the area of this portion. So now I have already told you that it has two surfaces. So B into del x on this side and B into del x on the back side. So B2B del x is actually the change in surface area. Okay, keep in mind two surfaces. Okay, so this is equal to T into change in surface area. Okay, so we get an important formula, and this converts into, this work converts into surface energy, or change in surface energy equal to surface tension T into change in surface area. This is an important formula. Del equal to T into del. Okay, so let us solve a problem on this. Problem number 10. Problem number 10, page number 400. Page number 400, problem number 10. This is actually, the figure shows a wire frame square type of frame, length of this 7 centimeter, length of this is also 7 centimeter. In this you have, I think, soap water film, na? There is soap water film. Keeping the film horizontal. Keep the film horizontal. Don't come in, not in vertical position. Keep it in horizontal position. Take a piece of thread. Take a piece of thread of length 22 centimeter and lay this piece of thread on that horizontal film you are holding it horizontally. On this horizontal film, lay this piece of thread to form an equilateral triangle. Okay, so okay, this is a piece of thread. Okay, so you have film outside this and you also have film inside this. The perimeter means perimeter of this triangle, this is actually the piece of thread, is 22 centimeter. Okay, now with a needle you prick the film occurring inside the thread. Okay, so you are holding it like this. Take a needle, prick the film occurring inside this. Find the surface energy of the remaining film. Surface tension is given. How much? 0.03 Newton per meter. Find the surface energy of the remaining film. Unless known to you, this will appear to be a tough problem to you. With the film occurring inside the thread remaining intact, film is remaining intact. As long as it is intact, the thread will remain in triangular shape. Because on the thread, surface tension is acting in this direction, because there is film inside also. On this, surface tension is exerting force in this direction. Outside there is film which is exerting force in this direction. Now you have pricked the film occurring inside it. So once you have pricked the film occurring inside, that means you have film only existing outside. Okay, so it will be pulled in this direction, in this direction, in this direction, in this direction, but there will not be any force inside. As a result, immediately the thread will take the shape of a circle. What will be the perimeter of that circle? So now you can easily calculate, do calculation. So now 22 centimeter, 22 centimeter perimeter. Use this formula. Change in surface energy equal to surface tension into change in surface area. Can you calculate the change in surface area of the film? Initially 7 into 7. Whole film. Initially 7 into 7. Now 7 into 7 minus pi r square. Okay? So you can calculate change in surface area. Change in surface area multiplied by surface tension. You will get change in surface energy. Shonatan?
Sir, can I do the surface consider both?
Obviously, both. You will consider both. Both the sides. But double. These are droplets of mercury. Okay, droplets of mercury. There are 27 such droplets. There are 27 such droplets, and the radius of each droplet is half millimeter. Okay, so there are 27 such droplets, and radius of each droplet is half millimeter. These mercury droplets, they come together and form a big droplet. Okay, mercury, remember, mercury has very high cohesive force. So whenever two droplets of mercury come together, they coalesce to form a bigger one because of high cohesive force. What is the surface tension of mercury? 0.465. It is very high. Okay. So these droplets come together and form, they coalesce and form a big drop. Okay. Question is, find the heat produced. Find the heat produced due to this. Surface tension of mercury is given. Surface tension of mercury 0.465 Newton per meter. Why will heat be produced? In droplet form, surface energy gets reduced, that is correct. In droplet form, the surface area is large. Okay, if the total surface area of 27 droplets, is greater than the surface area of this single drop. Always, whenever a thing is in powder form or in granule form, the surface area is large. But when they combine to form a lump, surface area gets reduced. Okay, finer the size, greater is the surface area. Okay, so surface area of total surface area of these 27 droplets is greater than the surface area of this single drop. So that means surface energy, total surface energy is also greater. Total surface energy of these 27 droplets is greater than the surface energy of this single drop. Okay, so that means due to this combination, surface energy gets lost, and the lost surface energy actually converts into heat. So that's why due to combination of these 27 droplets, a new drop will form, and that will become hot. Okay, so find the loss in surface energy. What is the first step? Calculate the radius of the bigger one. How will you get the radius of the bigger one? Constancy of volume. Apply constancy of volume. Total volume of these 27 droplets. By constancy of volume, half millimeter means 0.5 millimeter, so 0.5 into 10 to the minus 3 centimeter, so 27 into this equal to calculate R equal to this 3Q, 3.5, 1.5 now? 1.5 into 10 to the minus 3 meter. Okay. Now what will you calculate? Surface area. Okay, because change in surface energy equal to surface tension into change in surface area. So first we will calculate the total surface area of 27 droplets, then we will calculate the surface area of this single drop. Okay. Total surface area of 27 droplets, a surface area of one drop is this okay? 4 pi r square, 0.5 into 10 to the minus 3 whole square into 27, and surface area of the single drop 4 pi into 1.5 into 10 to the power minus 3 whole square. Hence, del A, change in surface area, del A equal to 4 pi into this minus this 0.5 into 10 to the power minus 3 whole square into 27 minus okay, so calculate this. Twenty-seven and 18, na? Is the calculation okay? So this is the change in surface area in meter square. Hence, change in surface energy. Change in surface energy, what is the formula? T into del M. T is this is the answer. This is a very important problem. Okay, very important problem. Generally from surface tension, this problem comes in exam. Okay. So we have derived two formulae. First we have defined surface tension equal to F by L, and then we have defined change in surface energy, which is equal to surface tension into change in surface area. Okay, now we'll finished. Now we'll discuss the pressure due to surface tension. Surface tension causes pressure. We will find the pressure due to surface tension. This is a soap film bubble. Soap film bubble. You find lot of such bubbles whenever you visit any fair, any mela. You find lot of such bubbles flying around you. We are considering one such bubble. Okay, so this is soap film bubble or soap water bubble. What is the pressure exerted by the film? That is the question. The film exerts a pressure. Film exerts a pressure. What is the pressure exerted by the film? This is comparable to a balloon. This is a balloon. If I ask you what is the pressure exerted by the surface of the balloon, then you have to calculate. Here also we will do some calculation to get the pressure exerted by the surface of the film. Before we go into that, first we should know whether the inside pressure is greater or outside pressure is greater, or whether they are equal. Okay, for consider a balloon, the pressure inside is Pi, pressure outside is PO. Which one is greater? Pi is greater. How do you know Pi is greater? Because if you prick the balloon, if you make a hole in the balloon, if you prick it with something, then air will come out. So that tells you that inside pressure is greater than the outside pressure. Because air comes out, air does not go in. Okay, and the two pressures are definitely not equal. Had the two pressures been equal, then after pricking, no air would have come out. Isn't it? If you have pricked the balloon and air is not coming out, in that case, Pi is equal to Po. But that does not happen. Always air comes out. That means inside pressure is always greater than outside pressure. Okay. Why is inside pressure greater than outside pressure? Now that is the question. So we have come to know that Pi is greater than Po. Now why is it greater?
So inside the area is small.
Not because of that. See, outside pressure is acting on it. Pressure is not a vector, but I am showing it as a vector. Outside pressure is acting on it. In addition to this, the surface of the balloon, it is a rubber body. So surface of the balloon, since it is rubber, it is trying to reduce its volume. The balloon surface, the skin of the balloon, it is continuously trying to reduce the volume or not. It has a tendency to reduce the volume. So the surface of the balloon, the skin of the balloon, the rubber of the balloon, that is also exerting another pressure. Okay, and the pressure inside has to resist the pressure due to the skin of the balloon and also the outside pressure for the equilibrium of the surface, because the surface is in equilibrium. Surface is neither going outward nor it is coming inward. That means the surface is in equilibrium. For equilibrium of the surface, the air inside the balloon, that has to exert a pressure which can balance the pressure due to the surface of the balloon and also the outside pressure. So we can write a simple equation, Pi equal to Po plus pressure due to the rubber. Is it okay? Have you understood this or not? So similarly in this case, this is soap film, soap bubble. This is soap bubble. Inside pressure is Pi. The surface, this is the surface. This surface is always under tension. Okay. It is also trying to reduce the volume, to reduce the surface area. So this is exerting a force, which is the pressure due to surface tension. And outside atmosphere is exerting another pressure. So Pi equal to, for this soap bubble also, Pi equal to Po plus Pt. Okay? You understood this? You will have to find the pressure due to surface tension. Okay? So write this question. Write. Consider a soap bubble. Consider a soap bubble. Find an expression. Find an expression for the pressure exerted by the surface tension in the surface of the bubble. consider this bubble, its radius is suppose R, pressure inside is Pi, pressure outside is PO. Okay? Net force acting on inner surface of the bubble equal to Pi into 4 pi r square. Okay? Net force acting on outer surface of the bubble equal to PO into 4 pi r square. What is the direction of this force? This force is outward. This is outward. And what is the direction of this force? PO into 4 pi r square? Inward. Hence, net outward force on the bubble equal to Pi minus PO into 4 pi r square. We have considered a net outward force because this bubble will expand now. Okay, the bubble is in the process of expansion. Suppose the bubble is growing, it is in the process of expansion, so there will be a net outward force, and the net outward force is this much. Okay, due to this net outward force, suppose the radius of the bubble has increased by dr. Okay. First I have discussed that the outward force acting on the inner wall. Then I have discussed the inward force acting on the outer wall. Then we have considered the net outward force. Okay. Net outward force. We have considered net outward force because this bubble is in the process of growing. It is becoming bigger. Okay. Due to this net outward force, suppose the radius has increased by a very small value dr. Is this point clear? So how much work has been done? Hence, work done on the bubble equal to this force into dr, because dr is the displacement, radial displacement. In the radial direction, the displacement is dr, and the force is also radial. Okay, radial force and direction is, and the displacement is radial. So this is the work done. Okay, so this, what has happened to this work? This much work has been stored in the bubble, in the film, as its surface energy. Okay, hence change in surface energy of the bubble del E equal to Pi minus PO into 4 pi r square into dr. Okay, now we know a formula for change in surface energy. What is that formula? Del E equal to T into del A. So now we'll consider del A, we'll find T into del A, and we'll make an equation using this. Okay, so find del A, change in surface area of bubble equal to, what is the change in surface area? What is the change in surface area? What is the final surface area? 4 pi into r plus dr whole square. And what is the initial surface area? 4 pi r square. Into okay, we will go for take r outside and then we will go for binomial approximation equal to 4 pi r square 1 plus dr by r whole square minus r square. But what about dr by r? Extremely small. Since it is extremely small, we can go for binomial approximation. 1 plus del x whole to the power n equal to 1 plus n into del x. Okay? So this is equal to 4 pi r square 1 plus 2 into dr by r minus 1 equal to 4 pi r square 2 into dr by r equal to 8 pi r dr. Is this the change in surface area? Two times this. Okay. Always we'll think about the writable area of a paper. You can write on this side, you can write on the opposite side. Okay. So the increase in this is a soap film bubble. It has got two surfaces inside. By surface we understand actually interface. Air bubble interface. How many interfaces does it have? Two. Okay, outside there is one interface. Okay, soap film air interface. Inside also there is one interface. Soap film air. Okay, so since there are two interfaces, since there are two interfaces, hence del A 2 into 8 pi r dr 16 pi r. Now we will apply the formula. Okay. Since del E equal to T into del A, hence since del E equal to T into del A, or how much is del E? Del E we have already calculated. Del E Pi minus Po into
4 pi r square dr.
4 pi r square dr. This is equal to T into del A 16 pi r dr. Okay. We will calculate Pi minus Po, and we know that Pi equal to Po plus Pt. Pi equal to PO plus PT. So if you can calculate Pi minus PO, from that you can calculate PT. Okay. Or Pi minus PO, dr cancelled 4, or Pi minus PO equal to 40 by R. Since Pi equal to PO plus PT, hence pressure due to surface tension, PT equal to Pi minus PO equal to 40 by R. Okay, so this is a very, very important formula. PT equal to Pi minus PO equal to 40 by R. Okay, now we have considered a soap bubble. Now I will consider a drop. A drop of liquid. If you consider a mercury drop or water drop, a drop has only one surface, only one interface. Drop. Just think about a water drop. It has only one surface or not? Inside, do you find another surface? There is no surface inside. When you consider a soap bubble, it has two surfaces, outside, inside. Two interfaces, outside, inside. But when you consider a drop of water, a drop of mercury, then it has only one surface. So for a drop, the formula is PT equal to this is for bubble in air. This is for drop, a drop of liquid. For drop of liquid. Again, consider a bubble in water. Okay, consider a bubble in water. Air bubble in water. An air bubble is rising from the bottom of a lake. An air bubble is rising. Now for this bubble, what will be the expression? 2T by R or 4T by R? Because this bubble has only one interface. Consider the bubble, air bubble, rising through water. Outside all water. So there is no surface outside. There is surface only inside. There is interface only inside. Okay. So that's why this will be PT equal to Pi minus PO equal to 2T by R. This is for air bubble in water. Okay.